Probably one of the worst parts about this repair was lifting this thing onto the bench. Man, it weighs a ton. Of course, we are talking today about an old school Dean Markley CD120 combo. Dean Markley, even though these days are mainly known for guitar strings and being like, an also-ran in that whole industry, also did, a run of amps and the likes back in the 80s. Most famously endorsed by Eric Clapton, Andy Summers of the Police. There was actually one that was out there that was one of Eric Clapton's rigs from the 80s that had a pair of Signature Series heads and some other stuff and all the rest of that got sold at auction. Bit of a different beast compared to this thing. So the CD series amps were kind of like the poor man's Mesa of the era. So 2 channels, overdrive, all that kind of stuff. Bit of a weird sort of implementation as to how things go. Half power switch, this one is 120 watts. Of course, 50 watt switching available as well. This is the 112 version, and it's sporting this absolutely lovely random blue color on it. It's also on the top too. Customers brought it in because he picked it up years ago at auction and just never got around to actually using it. Never powered it on, hasn't done anything like that, except for one time where he's plugged it in, turned it on, no sound, no nothing, which, okay, could be any number of things really. Apparently it was sitting there for a long time unused. This one is also a, American voltage one. So it runs on Yankee volts. As such, we have to make sure that we don't go past that 120 volt range, or else we're going to end up with a wonderful amount of the good old-fashioned magic smoke. Let's get this apart, look inside of it, and see, first of all, what's going on. I swear one day I'm going to implement a heavy amp surcharge. Just flipping this thing over is a nightmare. Ugh. Now, looking inside, probably one of the reasons why this wouldn't have had any volume is, first of all, we've got no preamp tubes in there. It did have one tube, though. Did have one. It was completely white-gated, though. It did have a crack inside, so obviously it's, let out the internals and the likes and went bye-bye. No preamp tubes, no signal. Now, if we look at the power tubes, come on, out you come. There we go. These are so incredibly old. These are so incredibly old, the country she no longer exists. Looking at the design on these though, coin-shaped base, pretty similar king, all of that. The same tubes that just kept being made for years and years and ended up being sold under new ownership when Mike Matthews and New Sensor bought up all the production throughout Russia, which is going to be a real big problem if this amp needs power tubes because, yeah, there ain't none. With Shiguang factory going bye-bye and now, of course, Russia being a bit of a pariah to the world, getting tubes is pretty damn hard. The price is going to be incredibly expensive. Hopefully these are okay. I mean, they look fine. The getters on them are nice and shiny. I'm not seeing anything that might, say they might be bad just from the outset, but of course we won't know until we test them and check them out and make sure they're not microphonic or having any issues. Interesting thing about this amp, the customer says he bought it from an auction and apparently they say it may have been an amp that was owned by INXS or used at some point. Obviously you hear stories about this all the time when it comes to equipment. Oh, some famous person owned it, 3 owners back and all that. But I just found this inside of the cabinet. That's going to be pretty hard to make out, but it does say Faris, as in one of the guitarists of INXS, so maybe this might actually be one of the old INXS amps. That'd be pretty damn cool. Let's see if we can find any more pointers in there. Another thing to notice about this amp is it is missing a screw there. It's got that one there. This one's also up here in the back. But they've got no washers or anything behind them, so that may actually split the cabinet if they're over-tightened. We want to kind of avoid that, so let's install some proper screws when we put it all back together. let's take a look inside the guts and see what is going on. Flipped up, ready to take a look inside. Big, hulking, massive transformers, like you'd expect of any amp of this sort of era. And of course, being a West Coast amp, this one has Schumacher transformers, EIA 606. Much like a lot of Fenders and Riveras and similar things of the era. 433, so based on the rest of the amp and everything I can see, and sort of when Dean Markley made these amps, this was probably made in 84-ish, 85, somewhere around that sort of period. So pretty reminiscent of its era, and if we look on the inside of the amp, we're probably going to see a sort of hybrid PCB point-to-point kind of thing. Let's see if my hunch is correct. Wait, stay. Called it. So this is going to be very similar to Mesa amps of the day and all sorts of other things where you've got your sort of guts of the amp on some PCBs, single-sided, none of that fancy multi-sided rubbish, hand sketched on there, so it would have been done with tape and all the rest of that and etched those ways, so there's no solder mask, nothing like that. And that's why it's all curved lines, so very similar to old Mesas of the era. From what I've heard, the inspiration behind these, of course, is that Mesa type tone of the era, your Mark IIBs and all that, but this is actually a little bit more sort of, you know, a little bit more control behind it than what you get from a Mesa. So you've got your individual gain and volume for your clean and dirty channels. A Mesa didn't really have that. You had your sort of overdrive type thing, and yeah. Over here on the rear panel, we've got power amp in, preamp out, as well as a send and receive for an effects loop with individual volume controls as well. So you've actually got send level and a receive level. That's pretty cool. You don't see that on a lot of amps, actually. It's a really neat sort of feature, especially because back when these were common, you would have had rack-mounted stuff for your fancy high-end expensive guitarists and pedal level stuff, so you wanted to make sure that you got enough level in for a nice clean signal, but not so much that it would distort or clip or create any sort of issues. Up the front here, we got us a PCB that has a lot of components wired on it, and all of the cables just running there through the guts of the amp. Looks like someone's worked on it previously. There's actually a couple of scorch marks on some of the leads here. They're kind of half melted. And IC caps, ones that like to spill their guts all over everything. Albeit this one is much older. It's probably going to have similar sorts of issues for all of that. So what we want to do is, before we go power things up or do anything else like that, check the caps, make sure they're all good. Check to make sure the ground's still connected where it needs to be. There's not going to be anything sort of short. Power it up on the Variac and take it away from there. Cool. Powered up, connected to the Variac. What we want to do is we want to keep an eye on the voltages as we sort of ramp it up nice and slowly. Make sure everything's all hunky-dory. Of course, the Americans like to flip things upside down. Good. Alright, so slide that up a little bit. Put that there. There we go. So we want to make sure that we're not getting anything too crazy on the voltage side of things. So we're going to measure things up, make sure everything's all good. Because I can see some parts in there that are sort of scorching a little bit. And hopefully there's nothing too crazy going on. These caps are definitely going to need to be replaced because they're older than I am. Let's see what happens. Nice and slowly. Straight away voltage galore. Nice. Yep, looking good there. Let's take a look at the power meter, make sure that's all hunky-dory. Where are you? There we go. Power meter. There we go. Power meter, nothing shorting out, thankfully. Yeah, 30 milliamps, about what you'd expect. We're up at 190 volts already up on the plate voltages. Yep. Cool. Oh yeah, voltage-wise, we're up at about 90 volts. Push it up a little more. Right about there. Cool. So, I'm pulling 300 milliamps, just quiescent current. There's no tubes in there at the moment. And we've got 513 odd volts there, which isn't too bad. Yeah, 1.1 volt ripple. Considering there's no load on there, it's about right. All right. So, we've got 500 volt redos there. Pull that off. What do we got on the next one? 262 over one more. Yep. Remove. Right there. 512 there too. That's a bit weird. Why are we getting 500 there? Oh, that's probably the screen voltage. Yeah, that'll do it. Cool. Yep. And then over to here. 400. 400. I'd say voltage is looking nice indeed. Cool. So let's throw some tubes in there and see if we get signal and all that kind of good stuff. And then we can see how it actually sounds and what it's doing. Bloop. There we go, flip the amp around the other way. The other thing we want to check as well, now that we've got tubes in there, is we want to make sure that we have bias supply on those tubes. We don't want them going red plating because, oh man, unless you've got a couple of spare kidneys, getting tubes right now is an absolute nightmare. Oof. We've got some amps in the queue that are just going to take absolutely forever to get repaired because getting the tubes for them is going to be almost impossible. Nice, nice. Yep, got negative voltage there for the bias. Sweet. Excellent. We've got voltages where we need them to be. Tubes are lighting up, which is a nice change. As previously, they had no tubes. Right on. So this is going to be one of those ones where in order to change channel, we'll probably need to connect up a foot switch. Use a 5-pin DIN, but we might be able to get away with just shorting out the contacts on there. I'll have to check with the schematic. Cool. Alright, so what I want to do is check to see if there's output on there. Output, check. Input, then, like so. Cool. Alright, let's get a bit of output happening there. Oof. Oh yeah, we got some crazy hectic volume going on there. Nice. Ooh, dusty, dusty pots. Very dusty. Big, big clean. Switches are all... Whoa, hello. That's a boost and a half. That mid boost just basically goes woof. Let's go there. Massive. Nice. Cool. So we've got signal, we've got all that going on. That might actually be a really easy job. Get those caps out, we'll replace them just for posterity's sake, because the last thing we want is for them to fail and take out anything else along there, because they're, God, they're ancient. How's the half power switch work? Yep. Power switch is doing its thing. Awesome. I like it when a job's nice and simple. Why can't they all be like that? Well, actually I know why, because then I'd be as bored as anything. Right. So let's see if we can't get this to switch channels and figure out how it does it as well. Alright, so jumpered the foot switch, because of course it is one of those ones where you got to shunt it to ground in order to get over to another channel. And we have drive. Can probably hear that transformer noise. Nice and loud and strong. I think we have a winner on this one. Oof. Yeah, that's some crunchy, crunchy pots. Yep, mid-range is still doing its thing. Phase control. Yep. Reverb can go away, we don't need that. Presence. So it looks like all we really need to do with this thing is throw in those new preamp tubes, bit of recap, clean up the pots, and then give it a good old-fashioned testing. So, next step, get the boards out, throw out the caps, throw in some new ones. Let's do it. Okay, so got the go-ahead from the customer. Let's get rid of these old caps to make sure they don't end up destroying things, because they're already going to start leaking and causing all sorts of issues. So we want to get them out, replace them with some nice shiny ones, so that the customer's not going to come back and see us in 6 months when they've exploded and shorted and taken a whole bunch of things out. Given the age of the amp, the first thing I'm going to do is apply some fresh solder to the joints, because once we've got some fresh solder on there, it's going to make desoldering it a lot simpler. All right. Sometimes to make removing a component easier, more solder is the answer. Put that little bit of extra solder on there, some fresh stuff. It just helps to make it flow, make it a bit nicer, make it a bit easier to deal with. And now, with those removed, we should be able to get those out with some ease. Question is, do I desolder the entire area, or do I just heat it up and pull the caps out? Let's see if we can just heat them up and remove them that way. Get a heat. No, they're still stuck well and truly on the board there. So a neat little trick to be able to get caps like these out that are glued to the board, and actually they've done a half decent job of it, is we cut the skin away. Go just down like so. Make sure we get through it. Because with that, we can go just like so. Now there's not going to be anything actually holding the cap directly in place. It's just holding the skin now. Covering the plastic, that thing. Cool. Nice. There we go. So now that we've peeled it, suddenly we'll actually have room to be able to remove that. Alternatively, what we can do to get rid of these caps is clip them off. Clipped off. Clip the other ends. Yeah, cool. Nice. All out in one go. Unfortunately, a lot of people clip them out and then just use these stakes to solder new caps in. Not ideal. Spend a little bit of extra time, get the board out, do all that, and it will just be oh so much easier. Alright, new caps are in. Time to solder them up in place. So a little bit of a bend on the legs there. Ting. Enough solder with enough heat to make sure that they're going to stay in there for another couple of decades. Even though they never did it from the factory, I want to get rid of that gunk on the board there, which is all flux, because that can be corrosive, it can cause shorts and all sorts of other things. So give it a good old-fashioned clean. Grab our scrubby brush. Where'd the scrubby brush go? There it is. And just try and get rid of as much of that flaky, crappy gunk as we can. Alright, caps are now in place, and of course put some high temp silicone on the underside there to make sure that they're not going to move anywhere. didn't put the same amount in as what the original manufacturers did because we don't need that much. We just need enough to hold them steady so they don't rattle around inside the case. Next step is we're going to reconnect these connections, put this back together, clean the front plate and make sure we get all the dust out of the pots and make sure they're all hunky-dory. Plug it in, power it up, and give it a test. Let's get on with it. Boards back in, caps. Like I said, normally I like to match them up so they're at least all the same brand, but the reality is, with the shortages of everything at the moment, just getting a hold of stuff's nearly a nightmare. Ideally, I'd like to have 105C rated caps all across the board. The two main ones, your primary reservoir filter caps, they are 105C rated, whereas the other ones are 85C rated. Not the best, but all things considered, what we can work with at the moment, not too bad. Time to do the front panel and all the other good bits, and then we can take a listen. This is a prime example why you always want to make sure you check every little nook and cranny inside of an amp, because once we've replaced all those caps on the main board for the high voltage stuff, there's actually one hiding up here on the front control panel. It's not just some little small teeny tiny thing either. This is a 22 mic at 350 volts, so that's definitely in the high voltage supply there. Right, so what we're going to have to do then is replace that one too. Always double check all these things, and of course we've got to clean these pots, and hopefully none of them are bad, because good luck trying to get anything that's going to fit that footprint. Yeah, so if one of those is broken, we're basically going to have to wire it to the front panel and then run fly leads to there. Here's hoping they're all good. Here is hoping indeed. Right, let's get this old chunky cap out and replace it with a new one. Alright, so now we're going to power it up with the Variac. Make sure we keep an eye on these figures. Make sure nothing goes wrong. Yep. Doesn't look like anything's shorting, which is nice. Cool. Good. Oh, so now we're just measuring off of the first reservoir cap. I'll get this up to 120, 110, a little more. 120. Cool. Yep. Good-o. So, looks as though we've got everything doing as it should. Power's there, that's pulling about what it should. Tube's lighting up nicely. Let's actually see what kind of signals we're getting on the output then. Signal gen hooked up, probed up, ready for the oscilloscope. Let's see how we are faring in terms of signal. Get a bit of volume there, pull up the master. Ooh yeah, clippy. Pull it back. That's a nice clean wave. Beautiful. Get a little bit more height on that. There we go. Ooh, yeah. And of course we can push it up into a bit more crunchiness. Cool. So you can get the clean channel to go into clip, of course. There we go. A little bit of break up there. Change the voicing modes. Yeah, it doesn't really do anything of that. Must just be for the gain channel. Bright. Yep. You can see there's harmonics being added. Mid boost. Woof. Oh yeah. Look at that. Look at the size of that jump. That's a big one. Nice. Cool. Yep. So we're not getting any terrible noise on the pots when we turn them like we did previously. Good stuff. Presence. A little bit there still. Oh, there we go. So that's dissipated as well. Just takes a couple of turns to get it all there. Half power switch still working. Yep. It's not really half, but you know, lowers the voltage. A nice little whack. Cool. Nice. Let us get a guitar plugged in here, throw it in the speaker and see what it's all about. Okay, powered up. Let's just quickly test, make sure it's all working as it should. That's not good. Alright, so we are getting some popcorning on the output stage, which says to me there might be something wrong with the output tubes. Which if that's the case, that's... oh boy, that's not good. Killing the volume, we still got all that going on. So we turn it back on. Yeah, we've got some lightning in the bottle going on here. It's not good. It's not good at all. On to the next thing to try and troubleshoot then. Alright, we've got some new tubes in there. Let's see what happens when we power on up. Yep, that's all fine. Nope, sound is still there. So, chances are that might be a screen grid resistor or similar that's gone bad. So we move on to the next of troubleshooting. This is one of those situations where you always want to make sure you get a really good close physical inspection. Because if we take a look in here, assumptive it's going to focus. There we go, a little further back, a little back. Nice. And it's not something that's going to be super apparent or super obvious either, but look at that grid stopper resistor. And someone who's previously replaced it and melted a whole bunch of things all over the joint. If we look there, we can see that it's actually missing a chunk of its cover. So regardless, we're going to replace those because that may have gone bad or something may have happened because one of them's already been replaced over on socket 1. But I also want to check these. I want to check these screen grid resistors, 470 ohm jobbies, because they may very well be causing that problem. Okay. Screen grids have been replaced, grid stoppers have been replaced as well. Noise has gone down a little bit, but it's still definitely there. So I gave board a bit more of an inspection, and what do I happen to find but this crispy resistor. There's a drop resistor between the 22 mic and the 33 here in the main filter stages. According to the schematic, that shouldn't actually be a 1K, that should be a 10K. So that's an entire order of magnitude less than what it should be. Sure enough, measure it up, throw the multimeter on there, and that thing is dropping 60 volts across it. 60 volts, 1K. That thing was running pretty well at 3 times its rated power handling. That's only a 1 watt resistor. That thing's not going to last that long with that much current flowing through it. So what we're going to have to do is flip the board back up and replace that with the correct value, which is a 10K, because that resistor's obviously been replaced along with some others at some point in the amp. There has been something that's literally exploded previously. So it literally went kaboom. And this one's been replaced, but it's been replaced with the incorrect one. It's lasted the years, but then, obviously it's been put away because something's happened to it or whatever else. And that's probably as a result of what happened. So let's get this board out and flip it up and desolder it and install the new one and see if that deals with the noise problem. Finally. Ugh. Every time we fix something, there was another problem around the corner. In this particular instance now, we've managed to finish up the effects loop, cleaned everything out, recapped all the high voltage section, changed out a bunch of capacitors around the phase inverter, changed the grid stoppers and the screen resistors on the power tubes, installed 3 preamp tubes on there, touched up a bunch of solder joints and some crusty wires, fixed up a bunch of utter terrible work done by someone previously that just had no idea what they were doing. In amongst all of that, we had to put some new bus bar wire and traces and whatnot on the loop board at the back there because they'd cut it, try to bypass it rather than actually just make it work. Replace both the FETs inside of there, replace the op amp that was dead, and finally, after everything that has been done, it is now ready to go back into its case. Hallelujah. That was a lot. That was so much. So, we've now got new foot switch. The great part about this is that there's actually 2 different ways that they switch. So I had to wire it up in 2 different ways. One of them for channel switching, which uses the LED in series with it going to ground, so it shunts to ground, doesn't need a current resistor or anything else like that, and that allows us to go between the 2 channels. The other one, for the loop, needs a reference voltage still, because it's either pulling it to ground or it's going to be at -15 on that there. So when it's at this point now, being pulled to ground, the effects loop is off, so it's bypassed. When we put that there, it opens the connection up. It's got an LED plus a 1.2K resistor, if I remember correctly, across there, which keeps the node at the -15 volts and allows our LED to do its thing, which means that, bam, signal can go through because it's using 2 FETs as series switches on them there. This was a lot more work than expected, but it's the joys of any kind of amp like this. Sat there forever. Needed a lot more work than you really expect. You find one problem, another one comes up, then another one, then another one. I probably could have gutted the amp and rebuilt something inside of here within that time, but you know, sometimes it's nice to just keep your skills up and do a bit of fun stuff. It's also kind of interesting because of how this amp works. So you've got your 3 12AX7s in there. 2 of them are providing the gain stages for the preamp section, but EQ stage and the reverb is actually driven by op amps. So the EQ is pretty different to your standard EQ setup. It's kind of neat, and it gives it a bit of a unique sort of feel once we demo this, sort of see how the controls interact with each other and what they do. And then of course we're going out to a quartet of 6L6s, pretty sort of standard. Yeah, that's really about it. So now that we've got this all rocking and rolling and it's doing its thing and changing whatever it needs to change, let's get it back inside of its combo, plug it in, test it, give it a demo, and send it on its merry way to the customer. Now that we've got all that all dealt with and fired up and all the rest of that, let us see how this thing actually sounds. So we'll start with things all pretty well neutral, everything up at good old-fashioned 12 o'clock. Volume on the clean channel relatively low because there's actually a fair bit of gain on tap there. You can really sort of push that thing hard. So let's see what we sort of get out of this. Look, it sounded better through the bench speaker that we have here. I think that driver's pretty mediocre. If it was me and this was my amp, I'd probably replace that speaker straight away. Very woofy, very kind of, yeah, just doesn't sound great. If we take a look at the controls here, treble, middle, bass, they don't work in the same way you'd expect a standard Fender type or Marshall type control stack to work. As we pull the treble control back, bass gets pushed a lot more forward. Kind of almost reminds you of a Baxandall type circuit, where you got your two-band Baxandall on there, turn one down, the other one goes up, turn them both down, the mids go up. So that's kind of interesting. Mid-range control is completely unique as well. We've also got a mid boost, which is kind of cool. Big volume boost there. Very, I mean, look, not great for the clean channel, very sort of quacky, very honky, very barky. Whatever adjective you like, really. Then, of course, bass control. So, you know, it works a little different to your standard though, so you probably have to wrangle and finagle a little bit in order to actually get a half decent tone out of this for your cleans. Bright switch, of course. Doesn't do a huge amount on the clean channel. Works, doesn't pull a huge amount in there. Presence control, pretty standard on that. That's probably about the most normal control on the entire amp. Now that we've seen what clean can do, what we're going to actually do is push clean a little further. Pull master volume back and push the gain up on there. Yeah, interesting, kind of British kind of crunch type thing. Neat. And of course we can dime it all the way up as well. That's pretty woofy there. I think I like it more down around there. There we go. Still not great, but it's okay. Let us take a look at some dirt though. Bonk. Once again, everything's just up. 12 o'clock. Volume, gain. It was the 80s. Things were labeled a bit differently. So, yeah, a bit of British kind of flavour thing there, almost American maybe, something. It's unique. It's its own thing. I don't necessarily like it a huge amount, but, you know, someone might like it. We've got voicing and bright control. So the bright control in this works a lot more. Hit the bright control. Yeah. Voicing switch, this is where it gets kind of very scoopy, very, you know, I hear a lot of people say these amps are like Mesas but cheaper, and I mean this is where you get the, you know, the bad Mesa tone, the one where people just scoop, scoop, scoop. Way too much bass. There's just nothing else to it. It's just, it's bass. Bass, 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 and more bass. Pull the volume down a bit, gain up a little higher. A lot of noise in this room. But, you know, there's that old school kind of 80s rock, metal, LA kind of sound. Yeah, definitely not having my best air guitar playing today. A lot of switch mode noise in this room. Absolutely terrible. Yeah, that's coming from the lights. I have to do something about it. I can come down a bit. And of course, voicing go on and off. Mid boost. Yeah, neat. Old school, some drop D type stuff. Well, this one liked to fight us the entire way along. At least now it's all done. I can send it back to the customer. If you got an amp, pedal, guitar, whatever, it's not well and you need something fixed, get in touch with us. Even if you're not local to the area, we get stuff sent in all across the country. So until the next time on the bench, we'll see you then.